Hello dear students, welcome to Become a Good Problem Solver event, BGPS event organized by the GEM Foundation. In this video, we are going to see the solution for the senior math problem published on November 2025. So in the GEM Foundation, we always encourage students to approach a problem systematically through the four-step process of UPER technique, which stands for understand, plan, execute, and reflect. So this four-step process, research proven by George Polya, will be very effective when children can approach any problem of challenging kind. Understanding a problem is very important as it helps a student's ability to comprehend a problem well. Understanding usually involves these kind of a four important process of underlining the key terms on what is the information given and what has to be found. Asking guiding questions, children are usually given guiding questions in the BGPS event, but as they understand what does guiding questions mean, they actually can ask on their own. And then drawing, visualizing, or rephrasing the given information so that they can comprehend better, and then looking for patterns as they work and finding relationships is a very important part of understanding. Come, let's apply the UPER technique to work on this math problem. Let's read this first. This rectangle tank is partly filled with oil and water in the ratio 3:4. 9,560 centimeter cube of the tank is not filled. If the tank contains 420 ml more water than oil, find the base area of the tank. At first, when students actually take a note of this question, they might immediately think that this is really a challenging question that they cannot understand and they don't know how to, work on it. And usually, when children are given such questions, the first answer that we get from the student is, I don't know where to start working on this problem or how to start working on this problem. This is a major concern for all children that they don't know where to start or how to start. So, this is when the UPER technique comes into handy. So here in this case, let's do a visual drawing of what they have shared so that we go to the next steps. So where to start is first try to understand what has been given and how to provide some connection to what is asked. So here it says there's a rectangular tank. So we know that the rectangle tank is basically like a cuboid, right? It's based on a rectangle shape, but a 3D part of it, which is like a cuboid. And what do you know in a cuboid? Is basically, this is the length and this is the breadth and this is the height. And since this being a 3D shape, you can find the volume of it. And the volume can be nothing but the area of this rectangle, which is length times breadth, and then this height times height. And then the area or the base area is this rectangle, right? Therefore, the word term base is being given. So the base area is nothing but length into breadth. So they have given the volume, but not the volume of the entire tank, partly filled tank, and they have asked us to find the base area. So now let's try to get into the next step of where to start. So you know that the area which is not filled, maybe you can just draw something like this. This is the filled part, right? And this is the unfilled part. So the area volume of this unfilled part is actually volume of not filled, right? Unfilled part is 9560 centimeter cube. So do you know how much is the volume of the filled part? We don't know, right? Volume of filled part, we don't know. But then if you see here, volume is given. If we know the entire volume, will you be able to find the base area? No, not specifically. Why? Because we don't know the height. If you know the height, you can actually divide, right? L into B into H. So area you can find where volume, if you know, you can divide by height so that this gets cancelled and you find base area. But then the height is not given. Okay, now pay attention to the picture. So that is why it is very important to have a holistic approach towards the problem. In this picture, you can see the small information given. What is it says? It says the height is 20 centimeter, isn't it? So this is when children might usually get astray that they may not pay attention to these details. So always pay attention to these details. Height is 20 centimeters. So now what you can have a mental plan is, if I know the volume, right? I can, the volume of this entire tank, I can find the base area because I can divide by 20 and can find the base area. So this is the plan that you can have. But how do I find the volume of the entire tank? I just know the volume of the unfilled tank. So now let's get into the another information of the guiding question. What does ratio mean, and visualize it with simple drawing and relate the information to 420 ml more water than oil. So now the information so far given we have utilized, but except this ratio and 420 ml more. So now what does actually ratio mean? So if for example it means 3 is to 4, what does it mean? If there is 1, 2, 3 parts of oil. So this is 1, 2, 3 parts of oil. Then the tank is having 4 the same parts of water, right? So they all should be same. Okay. If there is 3 parts of oil, then it should be 4 parts of water. This is what it gets filled up. And there is one important information given that it has 420 ml more water than oil. In this current state of filling, how much more it is? Basically 420 ml more, 420 ml of water more than oil. Okay, so now comes a very important relation or connection that you may need to do. So now you can see that this is oil and this is water, right? This way of drawing essentially should give you some clue. So 1, 2, 3, and this is 4, right? 3 is to 4, and the if the tank contains 420 ml more water than oil. So where can I draw this 420 ml is a very interesting point which will help you quickly understand the ratio. So this is exactly 420 ml, isn't it? Because this is what is more, one part is more, so and that one equal part is corresponds to 420 ml, because the other two are exactly same, all of them are equal units. So if one unit is more, which is 420 ml, what is this entire tank filled of oil and water, and with the ratio of 3 is to 4. So if one unit is 420 ml, like one equal unit or one equal part is 420 ml. How many equal parts are there involving both oil and water? Because it is made of both oil and water, right? How many equal parts, total equal parts, maybe you can say, how many total equal parts of oil and water are there? How to find it? Basically, if there is 3, this is 4. So, how many equal parts? It is 3 plus 4 is 7, right? Okay, so now take a pause. There are 7 equal parts. And what is one equal part corresponds to how much ml? 420 ml, exactly. So, if one unit is 420 ml, we have a total of how many units? 7 units. So, this is exactly the ratio comes into picture. So then how many is the total volume of the filled oil and water? It is 420 times 7, right? And that corresponds to 7 to the 14, 7 for the 28 and 29. So this much centimeter cube, or this is the volume, this is the ml, right? You can also say this is 420 ml or 2940 ml. But since we are talking in terms of cubic meter, we are writing it as centimeter cube. Okay, so now you already knew what is this volume of filled, and how did we find? We applied the ratio and the one equal unit. So now you found 2940 centimeter cube is volume of filled. So now pause for a minute. What will be your next steps? Yes, to find the total volume of the rectangular tank. And what is total volume? Unfilled is 9560 and filled is 2940. So your total volume is 15. Okay, so this is your total volume. So now that you have found the total volume to be 12500 centimeter cube, what is the question asked? Come again, let's be in track. It is asking about base area. And what plan we had? Oh, okay, yeah, base area. I just want to know the entire volume and the height. I'll get the base area. What is the height? Height is 20 centimeter. So how do I find the base area then? Base area is nothing but volume, which is L into P into H divided by H. And the volume, total volume of the tank is 12500 divided by 20 centimeter, which is nothing but, if you cancel this, you get 6 2s are 12 and then 625 centimeter squared. So the base area of this tank is 625 centimeter squared. So this is a very interesting problem. If you apply the UPER technique, it will help you with the guiding questions. It will help you take to the next steps of approaching the problem. So while at a glance it may find it a bit challenging, but as you work taking the thread along, it will be very interesting to see how the ratio is helping us to find the volume of the filled tank and how this important connection of volume and area has led us to find the answer easily. I hope you enjoyed going through this solution. Please do take a pause and then work on it own. It will give you a good confidence and participate in this BGPS event every month. The problem will be published in the 15th of the month and you have 15 days to submit your solution. Stay tuned to following the BGPS event by submitting and subscribing it to through the Gym Foundation website. Thank you, students. Bye.